Is that, yeah, that sounds as if it's picking it up. Excellent.
Well, I know one of the guys is running over, so.
Bubbly.
It is bubbly. Okay,
Yes.
so I do that, and then I think, is that really the way you're?
It's not the pronouncer of the stupid Canadian singer who's now taken my top spot on Google. Did you mean? No, I don't mean.
Yeah, I was just going to introduce you. Here I wrote me as a director of disruptive.
Yeah. And do you want me to try and do it to 45 minutes or an hour or?
So, we're starting late. We normally give you an hour. I would say, unless your audience disappears, I would just do what you were planning to do.
Okay.
Nobody's going to reject us, and there's no more food anyway. Okay, so I think you're good. Uh, 3:45. So, yeah, well, because everybody came late for overtime, so they're rounding up the audience right now. What happened is in the final one, somehow everybody ran over. So, but this is the very last, so we're waiting for people to be herded in. So have a cookie. 9, well, so by that it's 9. Yeah, we should be there. I'll just go right to the last. Okay, hurry back. Oh. The other end of the world, yeah. So Teresa, can you find what the status is of the roundup? Can you see where everybody is right now? Just maybe do a loop. Just check and see where the troops are, yeah. I don't think they've left. Just think they were all late.
Some people coming through.
Yeah, I can. I know some people left because they had flights.
Yeah. It's beautiful.
All right. Good. Joe, I got a quick question for you.
Whatever you want, whatever's convenient for you after it's done.
The question is, should I wait a few minutes or should we get started? Okay. All right, this is the last of the keynotes for the 14th Annual Real-Time Communications Conference. And we're delighted to have blockchain and distributed ledger technologies for telecoms and IoT, hype or here? I think this is really appropriate to have as the last talk because it's probably the newest technology and certainly the newest one that we're really trying to apply and see how it fits into real-time communications. And we don't quite know what we're doing yet. And so I thought the idea of hype or here is also very good, well chosen. And so we'll hear about this from Dean Bubley, who is the director for disruptive analysis. So thank you. Okay.
Thank you so much. Right. So I'm going to look at this from the lens of not just real-time communications, but networks, telecoms, and pretty much everything related to communications. So who am I? I'm an industry analyst and futurist. I've been on Twitter most of today making comments. Most of the time I'm quite snarky, but today it's one of my turn to get questions back the other direction. Yeah, exactly. I'm occasionally wrong. So I'm not going to stop before I introduce myself. I'm not going to bother introducing myself in any great depth. What I want to talk about is blockchain. But before I get on to blockchain, it's worth pointing out what else is happening in telecoms, because anything that either a service provider or an enterprise or a vendor is doing around blockchain needs to be seen in the context of everything else they're working on. And if I look across the whole space of sort of certainly my coverage remit, 99% of the management time and attention for most carriers or most large vendors, people involved in voice over IP and unified comms, is looking at everything from Internet of Things, 5G, fiber deployments, various new aspects of policy and regulation, security at all layers of the stack, pervades activities. Virtualization in the network, service providers and telcos are trying to launch their own cloud services, whether it's core or edge. They're looking at new consumer propositions around content, around fintech, around systems integration, and all sorts of other areas. So blockchain use cases and blockchain technology for the telecoms industry needs to fit in around these. And the nice thing for me, and I'll talk about this more as I go through, is that a lot of the value and opportunity is at the intersection points of ideally one or two of these other trends as well. And this concept of intersections is one of the areas that I'm really interested in from the point of view of business opportunity, research, and others, because it essentially is impossible in future for even a Google or an Amazon to do everything if you treat this as combinatorial. If you pick any one of these or any two of these, you can probably have a fair set of competitors on each of those cells in that matrix. As soon as you start trying to combine multiple ones, it becomes easier to differentiate, but also more dependent on each one succeeding in order to get it right. Another sort of step back and look at what's going on slide. I see two opposing sets of drivers in the industry, and there's a fundamental tension that I often see in communications between what I'll say you've heard about today with the programmable telecoms, what we'll talk about today with blockchain, which is this sort of left-hand side of this chart, democratizing things, commoditizing things, decentralizing, exploiting arbitrage opportunities. And then on the other hand, you have what I'll call the sort of centralization trend of how do we control, how do we optimize, improve efficiency, take out costs. Regulation often fits into this end of the spectrum as well. But perhaps most challengingly, particularly if you think about the requirements for large amounts of data, there is perhaps a tension between decentralization and blockchain and AI, particularly where you need large amounts of centralized data and information in order to generate insights. And that's, whilst there are some overlaps, it's worth bearing in mind that not everyone is thinking in the same ways as the people on the blockchain side of the fence when it comes to decentralization and fragmenting of control and data. So I'll use this metaphor a couple of times in the presentation, and it's like a sort of a grid, and the horizontals and verticals don't quite fit, but they give the idea. And the idea is to sort of say, this is very complex. If you look across the expanse of what people do in the telecoms industry and the conversations you have at one level, you may be talking to people about spectrum for radio networks and the physical access parts of connectivity, whether that's 4G and 5G cellular, whether it's low power wireless, whether it's Wi-Fi, whether it's fiber. Through the transport and core networks, we've heard about that as well, right through across to the services that get delivered to consumers or to businesses or to governments, whether that's a vertical like finance or manufacturing or transport, public safety. And then in the middle, you've got the things like the real-time communications, whether that's telephony, video communications, platforms as a service, and so on. And for each of those sort of vertical elements of the industry, there's a set of horizontal functions that need to be supported by the infrastructure or the IT systems behind that, whether that's around sort of planning, operations management, we've heard about testing and monitoring today, pricing and billing, fault management, management of the customer experience at various levels, whether that's B2C or B2B, dealing with an increasingly complex array of partners. So you might be thinking about, for network virtualization, it may well be that there's one vendor that's providing a framework, and then there's third parties that are providing the software functions with a new set of commercial relationships. And they are providing that platform to a carrier, which then has wholesale customers, which then have, I don't know, IoT partnerships. And we're getting into a complex set of supply chains around communications networks, whether that's for data or whether that's for voice, video, and messaging. And these are the sort of the background contextual setup to where blockchain fits. So a quick show of hands. Who is familiar with the general principles of what a blockchain is and how they operate? Probably about half, right. I'm not going to give a long session on what is blockchain technology. There's quite a lot out there, and it would take up the rest of the presentation. But to a first approximation, blockchains, and I'm using it with a small lowercase b, are decentralized, self-verifying databases. They're essentially a way of, rather than having a central database which is run by an authority, it could be a company, it could be an individual, it could be a government, it is a shared responsibility for maintaining a database between a number of parties that particularly don't necessarily trust each other. If you think at the moment of finance and banking, we have central databases called banks, and your account and the ledger the bank has is a trusted, you have to trust the bank to maintain the right numbers for your account. And two banks need to trust each other in order to transfer funds between people. This has come from the financial and transaction side of things, where obviously money has some fairly unique properties, like not being able to spend the same coin twice. Whereas with content, it perhaps doesn't matter if you make a copy of things, subject to copyright. Clearly, if you have a piece of digital currency, you don't want to be arguing with someone else as to who actually owns that Bitcoin or whatever other token. And so the Bitcoin blockchain is a way of, firstly, recording transactions, but secondly, verifying that there is a provable set of ownerships that are collectively agreed upon by a majority of people involved in creating and running that chain. And there's a sort of an incentivization method for that self-verification, which essentially is you pay people in the currency of the chain itself, so Bitcoin or Ethereum for the financial side of this. And that's essentially a price that is paid for the quite complicated mathematical processes used to do the self-verification. Whilst that is all fine for financial transactions, it's not immediately obvious how that then transfers across to other capabilities of essentially generalized databases that are not finance related. But essentially what this does is it changes the nature of trust about, should I trust a piece of data that is stored somewhere? Should I trust a transaction? And a transaction could well be nothing to do with money, but it could just be taking data from point A to point B, or it could be storing data for a while. Do I trust the data is what it was originally? Has it been changed? Do I trust, if you have multiple parties, that it is coming... do I trust that it's coming from the person I think it is? There's essentially a lot of sort of trust relationships, and at least in theory, blockchains provide a way of doing this without relying on central authorities that could be corrupted or that could charge you for stuff. It is worth noting that this term, the blockchain, gets used quite a lot. You'll often see people talk about, oh, put it on the blockchain. Capitalized blockchain with a capital B and a definite article, the, refers to the original blockchain underpinning Bitcoin. On the other hand, a blockchain is an example of the previous type of technology, and I'll come on in a moment to say that there's different ways of creating those. So there's a blockchain, which can be a variety of different mathematical mechanisms for what's this called the consensus mechanism. Some common ones that you'll find called Ethereum or Ripple, IoT, those are public blockchains. Now, huge and important difference here between public and private, or sometimes called permissioned blockchains. A public blockchain is one that anyone can participate in this verification process. Anyone can obtain rights to store data, to transact. Conversely, a private or permissioned blockchain is one with a finite number of members. It could be used in a consortium of companies. It's not a sort of an open to everyone solution or system. And that is more akin to a more traditional database, whereas the public blockchains usually come with some form of monetary or quasi-monetary reward for this process of verification, which is called mining, which is a term you may come across. Another point that is worth noting is that a blockchain can be an application platform in itself, because certain of these can support what are called smart contracts. And a smart contract is essentially a program which is self-executing and self-verifying. It is a way of using this database infrastructure to do a task. And that could be something like a smart contract for if the product is delivered to the person who ordered it in the right way and with the right conditions, then trigger the payment. That could be a smart contract. And it's done in software, so it's part of the fabric of the chain itself. And interestingly, one of the things we see is the most common sort of smart contract is actually creating a new form of blockchain on top of one of the mainstream ones. So a lot of the what you'll see referred to as the public cryptocurrency or tokens are actually ultimately based on the Ethereum blockchain underneath it. I'm not going to focus too much on public blockchains and tokens and cryptocurrency today. It's fun, and there's probably people here who've tried investing and may have made money or lost money, but I'll come back to that at the end. It's actually more the right-hand side and the permissioned and private blockchains, which I think are more important in the short term, simply because they're essentially a better and more innovative current way of doing databases. So there's a variety of terms you'll see used. I'm not going to go through all of this, but so we talked about the private versus public. Consensus mechanisms, another set of terms you'll come across quite often are proof of work, proof of stake, proof of elapsed time, proof of X. And that is called a consensus mechanism, and these are the mathematical approaches and computational approaches to this self-verification that I talked about before. Some of those come with downsides. Notably, they can be extremely highly consuming of power. One of the reasons that people are concerned about the original Bitcoin technology is that it uses roughly the same electricity of, well, last time I looked at it, it was Bulgaria. It may well be Portugal or somewhere else by now, because the mathematical problems that you have to solve for this self-verification are power inefficient at the moment. Others are more scalable. This is a slide actually borrowed from Microsoft, but I quite like it because it sort of gets to the core of the problem, as I'll go through in terms of talking what is real, what is near-term, what is far-term. It is where are blockchains, or this other term, DLT. DLT stands for distributed ledger technology. And that can be thought of as a subset of blockchains and adjacent technologies which are much the same. So there's a couple of others which don't necessarily have this sort of chain of transactions linked to each other. It's instead there's a different mechanism of linking or multiple transactions to each other rather than a linear relationship. So the way that certainly Microsoft categorized it was, does a particular process or transaction cross boundaries of trust? I.e., are you trying to put together a process which goes between individuals or companies that perhaps speak each other's language, but don't fundamentally trust each other? And then you could have different telecom operators in one country obviously have a common set of regulations, they know each other, they're essentially peers, but obviously at a business level don't completely trust each other, particularly where competition is concerned. On the other hand, is something which is, do multiple parties have to share data irrespective of that? And so a good example is interconnection between telecom companies, where obviously they have to sort of agree amongst themselves how many minutes one has sent to the other, or vice versa, or perhaps they need to share frequency and network characteristics along a border, or various other sets of data that are needed to be spanning multiple providers. It could be around fraud detection, perhaps. Is there a requirement for verification? Do those organizations need to have some way to be sure that they believe data? Or is there not generally a problem with either fraud or demanding authenticity? An example could be for law enforcement. If there is a request for numbers or call detail records to be handed over by a law enforcement agency from a carrier, how can the law enforcement agency be certain that the data that's been given to them hasn't been tampered with? What's the actual sort of proof of custody? How do you actually show that the person A called person B on this number at this time for this duration? What's the proof points of that? And the last one is, can intermediaries be removed? One of the potential advantages of blockchain is the ability to disintermediate, particularly where intermediaries traditionally have charged money or taken time or induced uncertainty or additional regulation. Now, the telecoms industry has lots of parties involved. So coming back to the previous point of, do you have transactions or data sets that need to cross trust boundaries? If you look at the number of types of technology, the number of types of company, the number of types of other organisation like government involved in communications, there's a huge set of these boundaries. Whether that's on the radio side, whether it's on voice, whether it's on Internet of Things, whether it's on emerging services in particular industry verticals, there will always be a diversity of organisations involved, whether could be roaming, for example. And that is only becoming more fragmented with the move to softwarization of networks and services. So you might have network function virtualization or software-defined networks where you have a new set of value chains from people providing the components of the software as well that need to be, for example, ensuring security. Is that piece of software what we think it is? Has it been changed in any way compared to a reference version of the software? And so on. So, where does this bring us? At a top level, I see three types and categories of use case for blockchains and distributed ledgers for telecom service providers. Probably the one in the near term, which is most prominent, is internal processes either within one service provider or between multiple service providers, where it's essentially providing efficiencies, streamlining interactions, perhaps with suppliers or regulators or other operators. And that's something which is fairly common across all industries. If you look at where blockchains are being adopted, it's for things like supply chain management or financial transactions where you've got cumbersome processes internal to the current structure of the industry itself. The next group of areas, and I'll give examples of these later on, are new services that can be delivered by communication service providers based on a blockchain platform. And that could be identity management as a service, for example. It could be mobile money or financial services. I've come across ones that are talking about using blockchain for new forms of delivering and selling connectivity and incentivizing the build-out of new networks in emerging markets. It could well be a new form of wholesale approach to wholesale communications or roaming, or even the ability to share data quotas between people, or voice or SMS. And the last one is where service providers or enterprises are themselves part of business ecosystems. Not necessarily telecoms only, but where they will be participating in other verticals. And this particularly crops up around Internet of Things, where you think about, it could be elevator maintenance on one hand, it could be a fitness tracker like a Fitbit, it could be all of the other different categories of IoT. There are lots of participants in that are providing the devices, the connectivity, which is obviously where the telecoms industry fits in, managing the data, managing the security, perhaps the power of those devices. And so we may end up with new ecosystems for, say, a connected car or autonomous vehicle, where a service provider like a telco could be of varying levels of relevance. But you may well find that all of the part players on that value chain are communicating or at least sharing data based on a blockchain technology. So, another one of these grids. So, where am I seeing at the moment the hotspots for blockchains in telecoms? So what I've got here is a different set of horizontals. The verticals are roughly the same as the previous chart, but the horizontals are, if you like, the primary typical use cases that people talk about for blockchain across all industries. So the top one is data integrity. Data integrity is the principle of asserting and proving that data has not been changed. So that could be, for example, for IoT, of actually verifying that the data that was recorded by my Fitbit hasn't been changed mid-flight between the device and the server. That's particularly useful, for example, for things like where you have intermittent connectivity and you have to store the data and buffer it before delivering it at a later point. It could also be to validate the software load in network virtualization. Is that software what we think it is? Comes back to the cool detail record example I gave before as well. Micropayments are fairly self-explanatory. There's a lot of interest in exploring using some form of cryptocurrency to support micropayments for content, particularly where the existing billing systems of people or companies in the telecoms industry, the cost per transaction might be too high to process individual payments that are perhaps for a short movie or something like that in another country. And it goes through, and there's a couple of these that I'll pick out. Smart contracts I've mentioned. Registries are particularly interesting as a horizontal. The telecoms industry has an awful lot of databases used as registries. For example, number portability databases, lists of licenses for, it could be radio networks, it could be point-to-point microwave links, it could be number allocation databases, it could be all sorts of rights and responsibilities being recorded. And those are interesting because they don't change very frequently, but they are often more commonly read than written to. And that's quite a good fit with a lot of the approaches to distributed ledgers. Identity management. There's various flavors of identity management. So a lot of countries around the world now have regulations where if you have a SIM card, you need to register that with the appropriate government authority, which is great if you live in a place where everyone has a birth certificate or a driving license or a bank account. But then, for example, you might have a problem of how do you register a SIM card as belonging to someone when they don't have any formal mechanisms for identification? Are there ways that people can self-identify and perhaps then have their social network or other groups sort of adding weight to almost like create a new consensus identity layer from scratch without government-issued documents? Supply chain management could well, again, refer to software or hardware, or it could be to do with data transferred for, say, roaming and settlement and interconnect. So there's a lot of possibilities here, and in fact, really each of these you can double-click on, and underneath each of these points there is half a dozen or more separate sub-use cases, and I'll give an example of that in a couple of minutes. Right, a warning first. There's an awful lot of people in the blockchain industry, if you like, who think that their hammer is the only tool that anyone will ever need. I encounter a lot of people who basically assert that the answer for everything is blockchain. There are very, very few examples of cases where there is no possible alternative mechanism to solving a problem to using blockchain. And one of the challenges for blockchain over the next few years is to go from these theoretical, putative ideas of what might be done with a decentralized system to actually prove that they are more reliable, more secure, cheaper, faster, easier than all the alternatives, particularly existing databases. So I would counsel caution whenever you hear people who assert that blockchain will inevitably change the world. It could just boil down in 5 years' time to look like, well, it's a slightly better database for 17% of use cases. That's a bit disappointing for some, but that's what we may end up with. On the other hand, you will certainly find people who talk about the chance of going all of the way to, well, actually, this changes the nature of what a company is, it changes the nature of what a government is, it changes the way we have trust in each other as a society, and there's a lot of people who will jump right to here and say we are about to leap into some bright new, either utopian or dystopian future where we don't need Facebook, we don't need governments, we don't need the tax authorities, we don't need X. We can do it all programmatically, provably, irretrievably, and that's possible, but I'm not counting on it for now. So where does blockchain make sense within the industry? Between what groups? Who would I advise to really give due consideration to this? And for me, the real sort of killer opportunities are where you have what in finance get called market counterparties, where you've got a bunch of companies or organizations that are broadly peers within their environment. It could be carriers, it could be enterprises, it could be software developers who speak each other's language but are looking for a better way of sharing data and managing transactions, ideally without a central authority. The other one which has come up recently in the last few months is this bottom one, which is the relationships between telecom companies and governments. And there's an intersection point of blockchain and what's being called regtech, regulatory technology. I'll come on some examples later on, where often the regulatory environment is cost-constrained and has some quite rigid rules, and again, lots of people who are involved but don't necessarily trust each other. I also think there's some opportunities around service providers managing blockchain-based services for communities. So there's some examples there where one of the Middle Eastern carriers is looking at managing healthcare data on behalf of the government using a combination of identity management and secure storage. Now, it's not immediately clear to me how that translates directly into blockchain. If the telecom company themselves are managing the system, that seems to be the opposite to decentralization. So I'm a little bit curious of exactly how that works. One thing I would also, on the caution slide, as well as the hammer and nail problem, is the press release problem. There's an awful lot of companies that will try to leave the word blockchain into a press release, even if it's of only tangential relevance. Another dimension to consider is timescales. Most of the distributed ledgers to date are quite slow to be updated. They're quite slow, they're expensive in terms of power and sometimes money, and this is particularly the public blockchains, but even to an extent the private ones as well. And if you look at the telecoms industry, there's a variety of different timescales over which the telecoms industry operates. And so here, things like number portability, you probably don't move your number more than once a year, unless you live in Indonesia and you have 5 SIM cards and cycle between them on a rapid rate. There are certain things which occur on a monthly basis, or, for example, reconciling of billing at a wholesale level between carriers. It could be daily reporting, but at the other end, you go right down to sort of seconds and milliseconds in terms of the internal management of networks. And frankly, at the moment, whether it's public or private, I'd probably put a line roughly down the middle of this in terms of blockchain suitability for anything which is changing in less than a minute or an hour is probably not going to be appropriate given the current scalability constraints of pretty much all the distributed ledgers out there. Just to highlight the problems here, the Bitcoin blockchain has a global throughput rate for transactions per second of, actually, does anyone know? The answer is 7. So 7 transactions per second on the current version of the Bitcoin blockchain. Now, there are others that can scale to hundreds or thousands, but if you compare that with the type of transaction rates you see in a network or in a credit card system, we're still quite a few zeros away from that level of scalability to date. So this is why at the moment I think the things which change on a relatively slow basis are probably the applications which are going to be the most interesting. Are they going to be public or private? Now, apologies for the complexity here, but my sense is that a lot of the opportunity is in the private blockchain space, so the white area of this, so between service providers, between telcos and their vendors, where you have a relatively fixed number of market participants. And it could be, there's, 800 mobile operators around the world, which is quite a large number, but it's not completely open to everyone. It's only where you start bringing in either end users, maybe media companies and developers and application developers, where you need to sort of perhaps move away from a permission-based approach to something that anyone can join in, because you don't want to have some sort of cumbersome sign-up. Although, that said, Apple seems to sort of run a permissioned app store, so maybe a future model could look like that as well. So I'm going to go through now. There's too many examples that have come out of people running projects. I'll be honest with you, at the moment, if you ask me, are there any real commercial day-to-day uses of blockchain in the telecoms industry, besides some of the managed service data integrity things, I am not aware of anything which is being used day-to-day and in anger. There are some market trials. There are a few public cryptocurrency-based products that are perhaps doing something, but in terms of people actually doing business rather than trading tokens or currency, we are still some way away. Where we are probably closest is in some of the more boring internal process functions of the industry. One example I like is one that was started by PCCW Global. PCCW is a Hong Kong-based operator, and Colt, which is primarily a European fibre and voice over IP operator, for doing wholesale voice settlement. And they're running a proof of concept which has been in phase 1, they're going to phase 2, and they're signing up additional partners. And the whole point there is that this process of settlement, where you get to the end of the month and you work out who sent whom what numbers of minutes, at what prices, and basically one party sends the other a check or transfers money, is hugely inefficient. Essentially no one actually wins from duplicating that system at both ends, having their own wholesale billing, then having a team of lawyers to deal with any discrepancies. That is not efficient for anyone concerned. And whilst the various participants might not each necessarily trust each other, they have a mutual interest in improving that process. For the industry as a whole, it adds nothing. And so this is where I can see an early use case of an existing clunky process that no one likes being replicated, but with a decentralized system. And it's scalable to a number of different operators that could be involved in that. So that, for me, would be a good example. And you'll be able to see on the slides later, there's actually, even within that, though, multiple different sort of sub-use cases. It's not just the process of billing, it's how do you do the financial settlement, how do you deal with any disputes and dispute managements. So what they've got is a trial where they say, well, if the dispute is less than, let's say, 10%, just forget about it. If it's between this bound, then escalate to this number of people, and if it's a huge discrepancy, then raise it as a proper human issue or something like that. So there's a lot of sort of subtlety involved inside this general pitch. The next one I want to talk about is spectrum management for radio spectrum. Is anyone here familiar with the term CBRS, Citizens Broadband Radio Service? Right, there's a few people. That's a new batch of radio spectrum in the US at around 3.5 gigahertz, so it's suitable for 4G or 5G networks. Normally with mobile spectrum, either on a national or large regional basis, auctions are done by the FCC here or regulator elsewhere, any other regulator elsewhere around the world, which says this bit of spectrum is assigned to this carrier for 20 years. And it's exclusive use on a national or regional basis. CBRS is an experiment that's being run in the US, where actually there's going to be a more subtle way of sharing radio spectrum in that band, where some of it is going to be dedicated in thin slices but smaller areas to particular carriers. But there's another batch of spectrum which is going to be, if you like, Wi-Fi-esque. Almost anyone can use it, based on what's called a sensing function. The current user of that band of spectrum is predominantly the US Navy, which uses it for things like aircraft carrier radar. Obviously, there's large chunks of the country where there aren't many aircraft carriers, and so that spectrum could be reused for something more useful. So the idea is, how do you create a system which shares that spectrum between, well, in this case, the incumbent, which is the Navy, a bunch of sort of what are called protected license holders that have some allocation, but on a smaller regional basis, which might be enough for a city, it might be enough for an oil refinery or something like that. And then how do you manage the sort of almost free-for-all Wi-Fi type use, but when even that lowest band has to make sure it's not interfering if the Navy does want to use the band. And so within that, there's lots of functions of databases, lookup functions. How do you manage, for example, to trade if you decide, actually, I can't get the network working at my oil refinery or my smart city, can I sell the spectrum to someone else? So there's lots of sort of use cases within that system. And there's a great piece of research actually done by someone from Nokia, actually, to look at what are the possible use cases that could be done with blockchain here. Now, the initial round of this won't be done with this, but this is perhaps for future study, and there may well be other spectrum bands which follow the same model if it succeeds. The other thing which I've noticed recently is various companies that are trying to create completely different approaches to underlying network protocols, essentially reinventing IP in most cases, either for wireless or for fixed connections, using some other form of consensus mechanism and rights. Some of these are associated with a payment mechanism using tokens, and some of them are just the technology. A couple of them here. I'm an advisor to one on the left called Ambertech, which is trying to create a multi-radio mesh system, particularly for emerging markets, where you combine Wi-Fi with TV white space spectrum, potentially with unlicensed LTE, and have incentives for, it could be a shop owner in an African village to deploy one of the systems for local use, which are paid in the sort of internal currency of the system. NKN is another organisation which is, again, trying to sort of, if I understand it correctly, reinvent IP. I've actually got a meeting with them on Friday. Whenever I try to read their white paper, I don't quite understand it, so I'm hoping that they'll be able to dumb it down a bit for me to be able to understand. Helium, another one I found online recently, which is a low-power machine-to-machine network that's decentralised, doesn't need a carrier as a central authority, but it also needs some way of for the people who participate in it to prove that they give coverage in the area that they promise to. Dutch operator KPN is deciding to go for more sort of a business approach to blockchain. So rather than actually doing a particular use case, they want to have a blockchain as a service platform for businesses in Holland, where they could basically set up and work with a utility company or a bank or I don't know, it could be a gaming company who wanted to create a blockchain-based application where they're actually underneath this, they're using IBM or Microsoft as some sort of building blocks, and then KPN offers additional services on top around IoT connectivity or security or functions in the core network. I think, for me, one of the other areas is around network function virtualization. There's a lot of internal capabilities of NFV, whether that's around the security of virtualized network functions, whether it's the accounting and billing for them, particularly where you've got multiple technology vendors involved, providing bits of software. How do you actually, what's the charging model? Yeah, if I've got a virtualized network and I'm running a microservice from vendor A, I'm running a virtualized, I don't know, firewall from vendor B, do you just buy it? Do you rent it by the hour, by the session? What's the sort of pricing mechanism? And how do you record the use of it in someone else's network? And I think there's some interesting approaches that are being worked on there. Regulatory. There's a couple of things that have cropped up recently. First one is the Indian regulator, TRAI, is trying to force the carriers in India to deploy a blockchain-based approach to users giving consent for SMS, marketing SMSs and robocalls, to the extent that it's essentially a way of doing opt-in, which doesn't involve the regulator having to spend lots of money on the database themselves. That's getting a bit of pushback from the industry, who think it's not mature enough, but it's going to be interesting to see what comes out of that. In the UK, Ofcom, the regulator, announced last week that it's researching how to do number portability database using blockchain. Now, that's particularly apparently the UK MNP system is apparently quite clunky and is roundly decided to be a pain by all concerned because it's been built up over multiple years with multiple layers. So if they can simplify that, I think they'll have some fans. But it's still very early days. I talked about the spectrum sharing aspects of it, and there's a bunch of other things around license management for various things in operators for both fixed and mobile. The other one is, and this is something I haven't seen discussed openly, but is one that I've been pondering, which is most places in the world there are data retention laws on consumer use of internet and devices, whether it's on calling or internet. There isn't, however, equivalent retention laws for network operations and the carriers, which, if you think about it, is potentially problematic. If you can imagine a future 5G network which runs power grid or IoT or services for public safety, and something goes wrong, either it breaks or there's a hack or something else, how do you prove the state of the network before? What's the equivalent of an aircraft's black box for networks? And I think that there may well be arguments, the more critical networks become for infrastructure, for services, and for sort of life and death applications, I think that there is likely to be a need for the equivalent of a black box. And I would say that the data integrity and data management capabilities of blockchain might lend itself to that. But again, to my knowledge, that's not really being discussed in anywhere near the level of depth that it should be at the moment. I'm going to speed up because I'm getting a little bit late. In IoT, one of the things I would say is that you look for IoT plus blockchain on Google and you will find thousands of hits. And what's not obvious when you first look at it is that there's lots of different things you could use distributed ledgers for around the Internet of Things. There's everything from device identity and authenticity. Is this a counterfeit Fitbit or is it a real one? Is there some way of storing device credentials online? There's the software versions, for example. It could be the security of the device, who gets access to it. There's connectivity, does the device pay for its own activity, perhaps with sensor data? Is there a trading, a marketplace for data versus connectivity? What happens when you go outside of the cellular network towards Wi-Fi? Is the user, do you have a loop through with a human, or is there some way to automate it where you can essentially have credentials both inserting identity and essentially allowing localized payment, and so on and so on up the stack. It's not obvious to me whether there is one silver bullet that can handle all of these capabilities of an overall IoT value chain or ecosystem. I'm not going to go through all the points you'll be glad to hear on this slide and the next one. You'll be able to download them afterwards, but these are, up to a few months ago, examples of existing telecom carriers that have at least made announcements about blockchain initiatives. Now, a lot of these you have to caveat with what I said before about the press release risk. Some of these are just sort of slapping the word blockchain onto a press release. I'm not going to sort of go through all of these and say which I think are real and successful. The ones which you particularly perhaps might want to pay attention to, the Sprint SoftBank TBCA soft one, that's a sort of a consortium group that's looking at doing reconciliation and cross-carrier money transfer, among others. Some of the stuff that Telstra in Australia is doing with IoT is also interesting. 3 US carriers, or 3 or 4, I think maybe all of them, have a thing called the Mobile Authentication Task Force, which is looking at seeing if there's a way of replacing passwords on mobile devices by using a collection of data points. It could be what network you're on, what device you've got, how long you've been a customer, the idea of your SIM card, your location, all sorts of other parameters. If you can then essentially combine that to actually almost like sort of fingerprint individuals and maybe use voice biometrics as well. So multi-factor authentication, where you perhaps store those variables on a blockchain as a secure way of sharing them between multiple carriers and perhaps application developers as well. The one I mentioned before, there's one right at the top, which is the PCCW and Colt pilot, which is using a platform called ClearX. And then there's a few others, quite a few interesting ones going on in South Korea at the moment. And if you look, the Korean operators are among the leaders, at least talking about this for now. So one thing I really want to sort of be clear here is there is no sort of top 10 list of blockchain use cases, any more than there's a top 10 list of database use cases or HTML use cases. There are so many possible theoretical uses, but we're still at a very early stage. So you'll see an awful lot of projects, an awful lot of suggested applications and solutions, and an awful lot of vendors. But in terms of where are we today, I would have to say that the ones that are looking most real tend to be the ones which are the slowest data changes, fixing existing problems, and frankly, it's probably the most boring ones, which are the ones which are most real. So these are, for the most part, also using private blockchains. I'll do a quick couple of minutes on tokens and tokenization and public blockchains, which I know is sort of an exciting area, although it varies in excitement depending on how many factors of 10 prices have gone up by in the last month. And at the moment, it's probably in the sort of the lull. We'll see if that continues to go down or not. There are various reasons why cryptocurrencies and tokens and tokenization are an interesting concept for communications capabilities. First off, this whole rise around ICOs that people may have seen last year and this year is a quick and easy way of fundraising, or at least it was quick and easy until regulators started taking an interest in it about 12 months ago. And now it's looking as if the people who found it quick and easy may well now be having attention from regulatory authorities they would rather not have. It's essentially, a token is a form of either, it's a way of either storing or transmitting value or utility. And this word utility comes up quite a lot. Is, can you actually create a currency which actually is a quantum of storage, of data transmission, of network speed, of minutes of communication, or some other sort of quantum of utility and application activity, which usually has an associated monetary value as well. The idea that you can get these smart contracts, so you have money which is automatically payable or that can be traded between people is very appealing. And lastly, there is this sort of ideology of we need to sort of move away from traditional, sometimes called fiat money and currencies. In principle, these are not new things. Frequent flyer points are tokens. Go to a casino and you get handed money tokens to gamble with. In a way, a barrel of oil is almost a token. You can trade barrels of oil, even without actually taking physical delivery. People trade them all the time. A ship going across the Atlantic the oil might change ownership 10 or 50 times because it's traded. Vouchers, coupons, are tokens. All of these are, if you like, non-money money, of varying levels of what's called fungibility, of trustworthiness. If an airline goes bust, the frequent flyer points are useless, probably. So you have to think about the sort of recoverability as well. The risk is that a lot of the cryptocurrencies that have been announced to date have been essentially, imagine you were building a casino and you wanted investors to invest in your casino to help you fund it, to fund the construction, but you paid them upfront in gambling chips. And the problem is that trying to sort of sell off the gambling chips before you bought the casino will probably mean that the price and value of those chips varies hugely before you actually get it built. And this is exactly what's happened with a lot of the cryptocurrencies today. They've been designed to help people trade network storage, compute capability, voice minutes, whatever it is, but they've usually been used to fund the software development. And so before there's actually a product, people are trading, the price is incredibly volatile. So these are some of the things that people have been trying to tokenize or create credits for. Mobile data quotas. Can you charge, is a gigabyte tradable between people? Maybe, maybe not. I've seen people trying to trade SMS, call minutes, mobile money, data. Can you create data from an IoT sensor location and trade that as a marketplace? I have to say that the views on this have varied an awful lot over the last 24 months, and at the moment, most people are pretty negative on the idea of these utility tokens. Not least because nobody wants to have 328 different currencies where you buy your beer with beer tokens and you buy your compute with CPU coins and all the other sort of variations on cryptocurrencies as well. I'm going to flip through these. These are, again, valid to a couple of months ago. I went through and tried to find all of the public cryptocurrencies and coins and tokens that people had announced, launched, promised that had something to do with telecoms or networking or communication. I will say that half of these are probably dead, and another quarter of them were either, I won't call them scams, let's say over-ambitious. Bubbletone's an interesting one. Bubbletones is actually one of the ones which is more close to being real. And that is actually a marketplace for mobile roaming contracts. And what they are trying to do is work with, in fact, this is what this slide I skipped past is actually, they're trying to do deals with mobile virtual network operators, MVNOs around the world, to get short-term contracts so that, I'm coming to the US, I go to a marketplace and I can say I get 8 days of usage and 3 gigabytes at this price, or I get a certain amount of minutes of use, or I do this and I get free Netflix for a week, or whatever it happens to be. And they're trying to create a marketplace for connectivity contracts. Sounds great in principle. I'm not 100% convinced that it works. At the moment, they're waiting for adoption of this technology, eSIM. I put this quote at the bottom. I've done quite a lot looking at eSIM, the embedded SIM cards that you can get in some Apple Watches and I think the later versions of the Google Pixel. In theory, they allow profiles to be pushed down to a SIM card rather than needing to go and get a physical plastic card from a store. It's a bit more subtle than that. It's the remote provisioning is the E. It's not the embedded. But it's in theory, the idea is you can turn up in Malaysia, select from some sort of online store what contract you want, and have your 2 weeks of data contract magically pushed to your phone. It's not as easy as that, but it's an interesting concept. So I'm going to wind up about here and say, is it hype? Is it real? There is probably less hype now than there was 6 months ago, but there's still a lot. Some of the hype has been punctured. Some of the projects are now moving on to second and third phases of proof of concept. But in terms of, are there lots of commercial implementations? No. My view is that on a 5-year view, certain things will be very important. But they're not going to be that disruptive. It's going to be stuff like registries. It might be a slightly better way of doing security for IoT. It could be better ways of offering credentials for virtualized network functions. Do I think that blockchain is going to completely redo either the enterprise or carrier industry? Aren't these sort of centralized service providers? Well, yes, but they're not going away because they've got 20-year licenses for radio spectrum, and there's an awful lot of physical assets which can't be decentralized very easily. So I think that we're going to see encroaching use of blockchain for certain historic database functions. We will see some new businesses that emerge from the telecoms industry around this. There will be, at the margin, some of the cryptocurrencies might make sense for the same way that things like calling cards do for certain communities. There are some interesting things around incentivized mesh networks for emerging markets. Do I think that we are going to encounter it on a day-to-day basis? Maybe if you are in, say, Kenya and you're doing money transfer from phone to phone. So there might be a future version of M-Pesa or Venmo here or something like that. But I don't think it's going to fundamentally change our relationships with carriers for now. But it might start to impinge on the vendor relationships and the software providers. And there's an awful lot of research opportunity for people who want to do cool stuff, whether that's looking at securing voice in various ways and call records, or at the other end to do with radio spectrum and wireless networks. Thank you. Any questions? Carol.
Yeah.
There's a microphone.
Okay. So it was a very nice, I guess, graphic of what would be good to use blockchain with and what would not, and I was therefore thinking that my phone calls would not. That is, we were specifically talking about, as you had WebRTC-based calls, would blockchain be your, and I think the answer is no, that would blockchain, because of the fairly long latency that's used, so I can't use it for an emergency call, for example. However, I could use it for part of a database. I would expect where I kept my records of the calls, things like that.
Yeah, I mean,
Yeah.
so you could say that blockchain would be a good platform for a sort of WebRTC equivalent of a call detail record, perhaps. That would be interesting. You could use it to store some of the quality metrics if you were sort of want to sort of have a monitor for ongoing quality of experience. I'm thinking back to what Varun was presenting from CoolStats earlier on. You could use that to sort of store records offline and then share them with a database while maintaining privacy. So there's an encryption and privacy aspect to this where you could potentially have that data held in escrow, which perhaps did not necessarily uniquely identify you, but could still be used for data management purposes or aggregation. But
Or
I'll have to
additional data,
Yeah.
like I could have.
I know Avaya have a solution which is trying to use identity management around devices as part of a contact center, so that rather than go through the rigmarole of what's your mother's maiden name and what's your address and what's your date of birth, it could potentially use data stored on a blockchain, anonymized, to recognize that it's you calling from a known device. So you could potentially skip through some of that registration process, which is an extension today of what you get on. I know my bank uses voice biometrics to log me on anyway, but you could then extend that with location, device type, perhaps other things.
Thank you. Dean, thanks again for coming. So the eSIM space is real interesting. I was wondering if you had studied that. I don't remember any comments from you. Maybe you have been. With the iPhone 10s, with basically 2 eSIMs in it. Now the U.S. consumer now can see what the equivalent of a dual SIM device looks like that like the rest of the world has seen, and so it's very interesting. But the standards around those eSIMs are actually not really telco standards. They're global platform standards. They're written by the people who do credit card encryption. So there's it's a landing spot for wallets, it's a landing spot for employee IDs and government IDs and maybe blockchain wallets.
There's some interesting, there's a couple of phones that are coming out which are being called blockchain-based phones. I saw a couple of announcements which, as far as I can tell, are ones which include cryptocurrency wallets, which seems a bit 2017 at this stage. I remember back in February when it was cool to have a cryptocurrency wallet. But I know Xiaomi and a couple of others are talking about those. But on the iPhone and the eSIM side of it, there's a lot of people who are sort of trying to sort of draw this parallel between eSIM and blockchain. I am not as convinced. In fact, I presented at an eSIM conference earlier this year, and I think that people are putting them in the same sentence, but it's more, they're a bit orthogonal to each other, and there might be touch points where you have a smart contract that defines your roaming contract, and it's then pushed down to an eSIM because that's a convenient way of doing delivery. I know IBM had a demo where they were talking about, imagine you had a vending machine with, I don't know, Wi-Fi hotspots or IoT devices, like a luggage tracker at an airport, and you could essentially buy the device, and they were using blockchain to share data between the vending machine owner, the IoT device manufacturer, and the carrier, and potentially the airport, to divide up the money between them whilst keeping all the data private and separate. But then, if you like, that's not actually linked to eSIM. I mean, it could be anything else in the vending machine as well. I mean, the only use for the eSIM there is that essentially it would allow that once all that's done, the profile could be pushed down the device.
You got to put the credentials somewhere. It's not a blockchain per se. You got to put the credentials to plug in somewhere.
And in terms of the iPhone, I mean, first off, I'm sort of quite pleased that I imagined that the first eSIM capable phones were going to have that dual SIM makes sense, because you cannot run a phone completely on eSIM until every carrier in the world, or where you want to sell it to, has this capability and willingness to do remote provisioning of the SIM profiles. And at the moment, only a very few do for certain use cases. And there's also no agreement on how and when and where you can switch profile A to profile B. Is it sequentially, or can I have 5 profiles preloaded in the phone and then switch amongst them on the fly? There are different approaches to eSIM. There's the one you mentioned, and then the GSMA official one. There is at least one lawsuit that's going on. It's a bit messy. And then there's also all sorts of practical issues with eSIM, and nothing to do with blockchain. So if I've got an eSIM-powered phone with a live profile in it, go, oh, this is great. I've got my new Verizon or China Mobile account. Oh, I dropped it. Screen cracks, and I've got a broken phone with an activated eSIM in it. What happens next? Do I take it to the store with the activated eSIM? How do I temporarily deactivate it? What happens while it's being fixed? At the moment, with this phone, if I drop it on the floor now, I can take the SIM card out of it. I've got an old iPhone 5 in a drawer somewhere. I can put the SIM card in it and get this fixed, and I've still got my phone. And I don't have to worry about the repair shop having the phone with an active SIM in it. So you need to think through all of these sort of corner cases, the user journey. If I buy a connected toy for my niece and it's got a SIM card in it, is it my responsibility to register it? Is it hers? Is it my brother's, whose daughter it is? What happens if it breaks and you need to take the connected teddy bear back to the store? How do you replace it for a different one? There's a world of pain. Where eSIM makes sense at the moment is on Internet of Things, where if you get a car that's shipped from a factory in Germany, and then it might go to the US and then be subsequently exported to Canada, or it might go to China. And what this means is that it can arrive in the dealership forecourt in Japan, and it can have a Japanese SIM profile pushed down to it. And in a car, you have vibrations, you have dust. You don't want to have a removable SIM slot. It's much easier if you actually just have it in the vehicle. And you might also want to change that SIM over time if you're Audi, let's say, and you get a better deal from SoftBank than you do from NTT Docomo next year. You don't want to be locked into a 5-year contract. You want to be able to change them. So I think for IoT, it makes a lot of sense, but I'm not sure on the phones yet. Not really blockchain, but I can talk about that anyway.
All right. Thank you very, very much.
Thank you.
Okay.
Thanks for the opportunity to speak. Really appreciate
A
it.
perfect way to end this. Where are we going? It's very nice. Thank you. Oh, now I'm talking out of 2 things simultaneously. So I want to thank everybody for coming to the 14th Annual RTC Conference. I hope everybody learned things and that you got a chance to talk to people, meet people, discuss ideas. So a couple of just bookkeeping follow-ups. If you go to the website where you can look at the program, and you go to the program page and click on program, there's a link there, you can actually see the description of all the talks you've been to. Now, everybody who has spoken and who has given us their presentation slides, those slides will be available up there. Okay, so that's the answer to the first question is, where do I get the slides? And the second question is, I guess, where do I get to see the spooled video? Because video was taken during the entire conference. And that should be to you in an email, because I don't know the answer to that, unless you can tell us right now. Okay. Oh, okay, can I find it on that same page then? Okay, it'll be to you in an email. Selection B. Okay. So again, I hope it was valuable. We're going to do it again. We don't have a date yet. And wonderful to have you all here, and give yourself a hand.